Hey everyone, so welcome back to my channel Mathematic Girls Party 3226. In today's video, I'm going to talk on properties of quadrilaterals. So we know we have, different types of quadrilateral, square, rectangle, rhombus, parallelogram, trapezium, kite, like these are the quadrilaterals that we have. So today in this video, I'm going to talk on the properties of these quadrilaterals that we have. So let's understand the properties of all these quadrilaterals one by one in a detailed way. Okay. So the very first thing that I'll tell you about the quadrilateral is what is the meaning of quadrilateral? Okay. So quadrilateral is simply, any shape in this world that has basically four sides, or you can say four corners. So every shape which are having four sides or four corners, they are going to be called as quadrilaterals, right? So for some quadrilaterals like, rectangle, square, trapezium, parallelogram, kite, rhombus, all these are, also quadrilaterals. They have a specific name. For example, we all are human beings, right? And we have certain names. Similarly, in quadrilaterals, like rhombus, kite, square, rectangle, all these are names given to the quadrilaterals. But unlike human being, there are some quadrilaterals in this world whose name are not given, but they are called quadrilaterals only if it has four sides or four corners. So for example, if I draw a shape like, this, see, it is basically, okay, I'll just do one thing here. I'll not convert it into shape. See, for example, if I do, this has no name, right? Not just this, but we have a lot of quadrilaterals that I can do. For example, this. See? Okay, so imagine it's just passing through the corner only. So all these are quadrilaterals, but we do not know the name. So yeah, so we are here going to talk about the properties of these specific quadrilaterals that we know. So the very first quadrilateral that I'm going to talk is on rectangle. Okay. So first, what I'll do is I'll write down all the quadrilaterals: rectangle, square, parallelogram, rhombus, kite, trapezium. Okay. All right. So before I start with the the properties in detail, I just want to tell you one common property of a quadrilateral, and that is, of course, I said in a quadrilateral, the very first thing is like this is the property that will be valid in all the quadrilaterals. Okay. So some basic properties of quadrilateral. First is it has four sides. Second is it has four vertices, you can say, angles, corners. So I'm just going to write down all of them together. So it has four vertices. Remember, vertices is a plural word of vertex. Vertices, corners, angles. Now, the very important, I can say the most important property of a quadrilateral, that is the sum of all the angles of a quadrilateral is 360 degrees. So this is something very important. Sum of all the four angles, because we have four angles only. The sum of all the four angles of a quadrilateral is 360 degree. Okay, so this is a very important property out of these three properties. Of course, the first two are very basic. And yeah, so these are the main characteristics, I can say, of a quadrilateral. Now let us talk about all these quadrilaterals in detail. So the very first is rectangle. So you all know how a rectangle looks like. So if I draw a rectangle, this is our rectangle. I can take the shape. Yeah. So you can see that in rectangle, we have, two pair of longer sides and two pair of short, or I can say one pair of longer sides and one pair of shorter sides. That longer pair we call as L, length. Okay. It's taking the shape. One second. Yeah. So this is called length. and length we will just denote by L. So of course the opposite sides are same only. So this is also going to be length only. And this we call as breadth or width. Okay. So now let us discuss the properties. The very first property is, I'm not going to write down it has four sides, four angles, four vertices, four corners, because that is something that I have already discussed in a general quadrilateral. So here I'm just going to talk about the other things. Also, the sum of angle A plus angle B plus angle C plus angle D is what, 360. That is something that you also know. So the very first is opposite sides are opposite sides are equal and parallel. Opposite sides are equal and parallel. Next is, this is very interesting property, each angle of a rectangle is 90 degree. So each angle of a rectangle is 90 degree. Next property. You can see here that we can draw two diagonals as well, right? So if I draw here two diagonals, what is the meaning of diagonal? Diagonal is simply a line segment joining the opposite corners, right? So here BD is one diagonal. Okay, imagine it's a BD, a proper line segment, and this is AC, another diagonal. All right, yes. So these are the two diagonals. And talking about these two diagonals, there is one property that we know, that the diagonals bisect each other. Okay, so the diagonals bisect each other, which means simply write down the two diagonals. The two diagonals bisect each other. Now, of course, I know you want to know what is the meaning of bisect. I'll explain that as well. Bisect meaning, very simple, bisect meaning cutting anything into two equal parts. So for example, here, this is the point where both the diagonals are meeting, that is O. So AC is bisecting BD, that simply means BO is equal to OD. And BD is also bisecting AC, that means OA is equal to OC. So that is why we can say that the diagonals bisect each other in a, in a rectangle. All right. Now next, so talking about the next property, which I'm not going to write down for the rectangle, because that I have already discussed, that the sum of all the angles is going to be 360 degree only. So I'll just write it because that is something very important. So I'll just repeat this. So angle A plus angle B plus angle C plus angle D is 360 degree. All right, that is it for the rectangle. Now we can go to the next, that is square. So square, how a rectangle is different from a square, or how a square is different from this rectangle. Let us understand that first. So yeah, this is a square. So unlike rectangle, in rectangle, we have the opposite sides equal and parallel. Here, the very first property about a square is, I just write down the corners name, A, B, C, D. So opposite sides are, okay, it is D. Opposite sides are, of course, parallel. That is correct. Of course, we can see the opposite sides are parallel only. Next is, here not opposite sides are equal, all the sides are equal. Okay, that is the difference between a square and a rectangle. In a rectangle, we only have the opposite sides equal and parallel. Here the opposite sides are parallel, but not only the opposite sides are equal, all the sides are equal. What does that mean? It simply means all sides are equal. And this is the short form of, that is AB, length of AB is equal to BC is equal to CD equals to DA. That is it. Of course, just like a rectangle, we have two diagonals here as well, BD. I'm just drawing it with my free hand. Make sure you draw it properly, like with a scale. So yes, this is the diagonal. And there is one property about the diagonal, that the diagonals are, the length of the diagonals are equal. So you can write down AC is equal to BD. Okay. And of course, there is one more property, that diagonals also bisect each other. So diagonals bisect each other. But there is one thing that I want to add here. Diagonals bisect each other. What does that mean? It simply means OB is equal to OD, and of course, OA is equal to OC. But there is one thing that we know, that AC is equal to BD, right? Because that is the property. So if the length of the diagonals are equal, that means this OB is equal to OD is equal to OA is equal to OC. So all the, I can say bisected diagonals, they are also equal to each other. So you can also write down OA equal, okay, one second. So it is OB equals OD and OA equals OC. And as I said, that the two diagonals are also equal to each other. So we can also say that OB equals OD equals OA equals OC. How? I'll tell you. For example, the length of diagonal BD is 10. And we know that the diagonals are equal. So AC is also going to be 10 only. So BD is 10, AC is 10. And they are bisecting each other. So this is also 5. This is also 5. Imagine centimeter. And of course, the BD is also bisecting AC. So this is also going to be 5 centimeter. This is also going to be 5 centimeter. Can you see that all the lengths are equal? OA is also 5, OB is also 5, OC is also 5, OD is also 5. That is why we can write down OB equals OD equals OA equals OC. All right. So this is something that is very important if you are solving the questions. All right, next is like rectangle. There is one similarity that each angle of a square is 90 degree only. So each angle of a square is 90 degree. And of course, the sum of angle A plus angle B plus angle C plus angle D is 360 degree only. Next is the diagonal basically bisects the square into two equal right angle triangle. That is also a very important property. So you can write down that the diagonal bisect the square into two right angle triangles. Right angle triangles. Now, why right angle triangles? Let us understand that. So simply you can see that each angle of a square is 90 degree. That means this is 90 degree. And if this is 90 degree, of course, ABC is a right angle triangle, because what is a right angle triangle? Any triangle with one angle 90 degrees is called a right angle triangle. Similarly, this is also a right angle triangle. So if you talk about diagonal AC is dividing the square into two equal right angle triangles, ABC and ADC. And if you talk about diagonal BD, that diagonal BD is basically bisecting the square into two equal, again, right angle triangles, that is ABD and BCD. That is it. All right, so this is the property. These are the properties of a square. Now we can go to the next one, and that is a parallelogram. So we will go to the third quadrilateral, and that is parallelogram. So first of all, let us just see the shape of a parallelogram. So this is the shape of a parallelogram. Okay. So the very first thing about parallelogram is that the opposite sides are parallel and equal to each other. Okay. So you can simply write down here first property as opposite sides are parallel. In this particular picture, they're also equal. So opposite sides are, not just in this, but in general, they are equal only. So opposite sides are parallel and equal. Okay. Next property we have is, the diagonals bisect the angles. Okay. So for that, I'll draw the diagonal here. Just like earlier we saw that a line was bisecting another line. Here the line is bisecting the angle. What does that mean? Let us understand that. So ABCD. So clearly you can see that diagonal BD is bisecting angle ABC. What is the meaning of bisecting the angle ABC? That means this angle will be equal to this angle. Similarly, AC diagonal is bisecting angle BAD. What does that mean? that this angle will be equal to this angle. BD is also bisecting angle ADC, so this angle is equal to this angle, and AC is bisecting the angle BCD, so that means this angle is equal to this angle. So I hope you understood this, and I'm simply going to write down that the diagonals bisect the angles of a in a parallelogram or of a parallelogram, whatever you want to write down. So that is the second property. Now next is, here the diagonals are perpendicular to each other. They bisect, of course, diagonals bisect each other, but they also bisect each other at 90 degrees. Okay, so let us understand that. So we can write down here that diagonals bisect each other at 90 degrees. Okay, so this is the next property. Next, we can write down that basically, of course, all the angles are 360 degree if you do the sum. So the sum of angle A plus angle B plus angle C plus angle D, that is going to be 360 degree. Okay, remember one thing, there are of course more properties than these, but here I'm just covering the basic properties that one should know. If you want to make me the detailed video on all these properties, like the congruency, the similarity of the triangles, everything, how a diagonal is bisecting a square into two similar triangles, to congruent triangles, all these things, if you want, I can make another video for that. In this particular video, I'm just covering the basics of these quadrilaterals, the properties of these quadrilaterals. All right, let's next go to the kite. Okay, that is the fourth quadrilateral. So there is one difference. Okay, before going to kite, I think it's better if I cover rhombus, so that I can tell you what is the difference between rhombus and kite. So this is the next, that is rhombus. So rhombus basically looks like this. Okay, this is our rhombus. It looks like a diamond as well. So A, B, C, D. Here, the only difference between rhombus and square is that each angle of a square is 90 degree, but in a rhombus, each angle of a rhombus is not 90 degree. Okay, that is the difference. So now let's write down the properties. The very first properties are all sides are equal. Of course, all sides are equal. And now talking about the diagonals, I'll just draw the diagonal with my free hand. So diagonals are basically diagonals bisect each other at 90 degree. Of course, it's very clear, it's visible. Diagonals bisect each other at 90 degree. Next is, just like a parallelogram, the diagonals also bisect the angles. So I'll just write on that as well. Diagonals bisect the angles. Now next we have the last one, which is the common one, that the sum of all the angles is 360 degree. So let's write down that angle A plus angle B plus angle C plus angle D is equal to 360 degree. Now let's go to the kite. Okay, so talking about the fifth quadrilateral, that is a kite. Let us draw the shape and let us see how is it different from a rhombus. So this is, okay, I think this is going to take the shape of a rhombus only. So I'll do one thing. I will draw this with my free hand so that you can understand the difference between a rhombus and a kite. All right. Okay, so that is kite. And now let us draw a kite. So for that, I'll just use my free hand. So this is kite. Unlike rhombus, in rhombus we had observed that all the sides are equal, but here all the sides are not equal. Only the adjacent sides are equal. right? And here the lengths of the diagonals are also not equal, and that is very obvious, right? So this is A, B, C, D. So here the adjacent sides are equal, the length of the adjacent sides. For example, AB is equal to AD. So that is the first property. The adjacent sides are equal, and that simply means AB is equal to AD. Adjacent sides are equal. That is AB is equal to AD and BC is equal to CD. So that is one property of a kite. Next is, of course, the sum of each angle is 360 degrees. So I'll just write on that. Angle A plus angle B plus angle C plus angle D is equal to 360 degrees. All right. So here there is one very important property about kite, about the diagonals. Okay. So one diagonal is basically the perpendicular bisector of the other. And of course, you can see here that we are having two diagonals. One is the longer diagonal, that is AC, and another is the shorter diagonal, that is BD. So here the longer diagonal bisects. That means AC bisects BD. That simply means OB is going to be equal to OB, right? So here the longer diagonal bisects the shorter diagonal at 90 degree. Of course, you can see that the shorter diagonal is not bisecting the longer one, because of course we can see that the lengths are not equal. Now, next is the diagonal bisect a pair of the opposite angles. What does that mean? Simply, you can see that here the longer diagonal bisect this angle and this angle. So AC is basically an angle bisector which bisects both the opposite angles. So you can also write down the longer diagonal is also an angle bisector. What is the meaning of angle bisector? It simply bisects the angle. So it bisects this angle is equal to this, and also this is equal to this. So we can simply write down the longer diagonal is the angle bisector. And that is it. Is the angle bisector. All right, so now we can go to the next, and that is trapezium, and that is also our last quadrilateral. So talking about trapezium, how trapezium is different from, parallelogram, let's see that. So trapezium basically looks like this. So in trapezium, you can see that one pair is, parallel, but another pair is non-parallel, okay? So you can just, whatever I said, I'll just write down using the symbol. So first is AD is parallel to BC. AD, so that is the first property. AB is parallel to CD. And AD is not parallel to BC. That is something that you have to remember. In a trapezium, only one pair of the opposite sides are parallel, and the another pair of the opposite sides, they are non-parallel to each other. If both the sides are parallel, then it will become a parallelogram. Otherwise, it is a trapezium. Here, this is the first property, and of course, the second property is going to be the sum of all the, four angles is going to be, 360 degree. And now the next is the property of sum of the adjacent angles. Here the sum of the adjacent angles is 180 degree. Angle A plus angle D is 180 degree. Basically, it is valid in the other quadrilaterals as well, but I have just mentioned it here because we do not have many other properties in the trapezium. So angle A plus angle D is 180, angle B plus angle C is 180 degree. The reason is basically, the parallel line and the transversal line that I'll explain you in detail in some other video. Right now, you can just write down the property. So this is the second property, and third is simply you can write down the sum of the four angles is 360 degree. That is it. So these are some common properties that I have discussed in this particular video. For the detailed properties like congruency and the similarity and the other things, you can just let me know. I'll just make another video for that. Now let us come to the very important thing, which you can see right here, that why is this sum of the four angles of a quadrilateral is 360-degree only and not any other angle. So let us understand that. So for that, I'm going to draw a quadrilateral. Any quadrilateral I can take. I'm just taking a random quadrilateral. And let us see that why is this going to be 360-degree. So this is A, this is B, this is C, and this is D. Right? Okay. So here I'm going to draw the diagonals first. Okay. So we have the diagonal, one diagonal I'll draw. So I am joining AC. Okay. Imagine it's just going like this only. Okay. So as soon as I joined the opposite corners, that is, as soon as I have made a diagonal, you can see that we have two triangles. First triangle here, another triangle is here, right? So you can just say that we have two triangles. One is this green region, right? And then another one is the white region, you can say, but I'll just color it. That's the pink region, right? All right, so we have these two triangles. Now, there is one very important property about triangle that we have understood, and that is the sum ASP. That is called angle sum property. And what is angle sum property? That sum of all the three angles of a triangle is 180 degree, right? So imagine this angle is angle. Let me just take a color. Yeah. So imagine this angle is angle 1. This angle is angle 2. This angle is angle 3. This is angle 4. This is angle 5. And this is angle 6. Now, what I'm going to do is, I'm going to take one triangle first. That is, let us talk about the green one. So that is in triangle ABC. One second. Yeah. So in triangle, so okay, give me a moment. So in triangle ABC, of course, using the angle sum property, I can write down angle 1 plus angle 3 plus angle 4 is 180 degree using the angle sum property. And I'm writing this as equation 1. Now I'll talk about in triangle ADC. Of course, we can see the sum of angle 2 plus, sum of angle 2, 5 and angle 6. It is also coming 180 degree only because that is also a triangle, and using the angle sum property, we got this. Now what I'm going to do, I'm going to add both the equations. Now remember, whenever we add the equations, we add the LHS with LHS and RHS with RHS. So here this is the LHS and this is the LHS, and this one is going to be the RHS and this one is going to be the RHS. So we will add the LHS. So this will become angle 1 plus angle 3 plus angle 4 plus angle 2 plus angle 5 plus angle 6 equals 180 plus 180, right? Now here what I'm going to do, I'm going to write on angle 1 plus angle 2 together, right? For this angle 3, I can write on angle B because that is the name. So angle B. Angle 4 plus angle 5, I'm going to write down together. And angle 6, I can write down as the angle D only because that is angle D. 180 plus 180 is 360. And now you can simply observe that angle 1 plus angle 2 is nothing but this complete angle, that is angle A. So angle 1 plus angle 2 is nothing but our angle A. Plus angle B as it is. Plus angle 4 plus angle 5 is nothing but angle C. And angle D as it is. So that is 360 degree, and that's the proof. So yes, that is the end of the video. There was some glitch from my side which was happening. That is why I was keep on, stopping the recording, and then I was coming back. So yes, thank you so much for watching my video. And if you have understood the video properly, do let me know in the comment section as well. Again, I'll repeat here, I have just covered the basic properties of a quadrilateral and not the properties in detail. If you want me to make a detailed video on all the properties, one by one, of course, I'll do that as well. So yes, thank you so much. And I'm hoping to see you super soon.